Well, I hope you challenge yourself, and I would imagine that the very last one, the bottom two, actually would be the most challenging. And I want you to take a close look at my r theta, and again I messed up and put xy there, but look at my r theta. I always start at 0, and then on this first one I chose pi over 2, and I ended up on an axis as well. Oh no, I didn't. Yeah, I guess I did. I ended up on an axis, and anyway, 1, 2, 3, 4 key points, and then back at 2 when I put 2 pi in here. So this is what we call a cardioid. It's a common, you could type in cardioid and look that up on Google, and it's just a typical curve and polar. And this is special limacon, by the way. This is a limacon. We're going to talk more specifically about these types of polar equations in which, if you notice here, 1 plus 1 cosine theta, anytime that these two numbers here are exactly the same, you're going to get a cardioid that starts in a place like this, out here away from the pole, and then it hits the pole and then comes back around, and takes 2 pi radians to do that. This is a special, this is a limacon in which the first number is bigger than the second number, and when you think of the first number being bigger, the curve doesn't come back to the pole. Okay, so it stays away from the pole, and then but it does come back around at the end of 2 pi. Okay, so when the first number is bigger than the second, that's what happens. It doesn't come back to the pole. It can't get back there. And then, if you think about it, r can never be 0 because cosine of theta can never be -2. It's always going to be at the smallest, it'd be -1. So r is 1 when cosine is -1, and that's pi, and we saw that. Okay, the other thing I want to point out is when the first number is smaller than the second, whether it's a minus sign here or a plus, 1 is smaller than the 2, you're going to get another special type of limacon in which the curve not only gets back to the pole, but it makes a little loop. So it comes back to the pole and it makes a loop here, and then comes back around at the end of 2 pi. Okay, so you can see one of each. The two numbers are the same. First number is bigger. The first number is smaller in absolute value than the second number, and you get a little loop. So these are the special kinds of limacons that we're going to be studying, and then this would be one of those rose curves in which you get like a little flower. And again, first try, you're just learning how to graph polar functions, and so these can be a little tricky, and you have to pick convenient values for theta so you can see what's going on. And so anyway, we'll talk about this more in class, but if you got this, that's really impressive. I think that the last one that I had you guys do, if you got that one, very, very impressive. But if you look at my coordinates, you can see why. The first time you can get back to the pole would be at pi over 6, and so you kind of come up here a little bit, and then right there at the pi over 6, you see it goes right there. Anyway, you'll be memorizing these and being able to do these pretty quickly if you put the time in, like you've put the time in to your unit circle. Have a great night. We'll see you in class.